This is the first challenge in Quantum Odyssey. Why is it a challenge? It's because now it matters how many gates you place. Nothing else matters except the number of gates you place in your final circuit. You can make as many mistakes you want. You can take as much time as you want. What really matters is how many mistakes, how long is your circuit at the end. Basically, how many gates you place in total. For certain items, for certain puzzles, the challenge, you might get an optimizer key, which means the solution you find is better than the solution that we knew it's an appropriate solution, meaning you have created a super optimized quantum algorithm and you should get a special reward for doing so. The first puzzle, again, straightforward, proves reversibility. Second puzzle, again, asks you to put a gate on the second qubit without instructions. Quite straightforward. Then again, we have a situation in which we need to reverse two existing gates. Simple. And then what we discussed in the previous tutorial, just flip the middle one, don't do anything to any of the other qubits. And now we have an existing gate in the middle one, meaning we don't need to put anything there. As we can see from the solution, simply adding two gates here would be enough. Then, okay, now again, we have a situation in which the middle needs to be flipped. So basically we leave it unchanged, but we nullify the flip on the leftmost and rightmost. And now we have again another situation which kind of shows you about the fact that the visuals, although they might be asymmetrical, what we had before are not doing more than just telling you the directions, but they will not affect the final state. So now in this example that contains 4 qubits, this is again 4 qubits means 16 possible total states. So to get 1, 1, 0, 1, this means qubit 1 is 1, qubit 2 is 1, and this is left the way it's right now, and the last qubit has to be 1. Of course, I can make something completely unoptimized, which would mean something like this, which again, it would be a valid solution because these two reverse, right? And as you can see, I'm getting to the main state because, yeah, these two simply nullify each other. Now, again, I'm starting from 1, 1, 0. This means the leftmost and the second that follows have to be flipped. Solution is achieved. And for the last situation, this is the big mess, just to prove the point that all you need to know is where the final state is, in this case 0, 0, and you need to go to 1, 1. I can completely ignore what's happening on the screen and simply drop an X gate on every possible slot. Make sure I don't have more than one, and that's it. I got a solution. That's all you need to know.